This is Pre-Calculus, Functions and Graphs. I'm Mr. Stark. Thank you so much for joining me. We're on topic 2, which is titled Functions and Their Properties. This is lesson 2, simply titled Functions. It's one of 4 lessons in this topic. We'll be using this document for our notes, so here we go. The concept of functions are seen all around us in everyday experiences. So I'd like to think about some of those examples before we define a function and see what a function looks like. Let's create a table that has 3 columns, and this should take up about half of our space here. The first column is titled Function, the next one Domain, and finally Range. We're trying to come up with some examples of functions. I have a few, but I want you to think about some as well. You could think of them as machines or situations in which there's an input and an output. So here's a good one, a vending machine. The input is money. You put money into the machine and out comes your snack or food. So can you think of one? How about this one, a paper shredder? You input paper and the output is paper shreddings. Some other examples that I won't write down include your account balance for your bank. You tell them the date and it gives you a balance on that date, or you could see it online. Another one is a velocity function, that if you input a time, that function gives you a velocity. Okay, the last one is this. A good example of a function is y equals f of x. It's a function based on x. So therefore the domain is all input values, all the x values. And the range is all of the outputs, or f of x values. In Algebra 2, we thought of them as just y values. Now that we understand what a function is by example, here is a definition of a function. It's a rule that assigns a unique value in R, the range, to every value in D, the domain. When there's more than one value in the range that corresponds to a specific value in the domain, then it's not a function. The nice thing is we could see this graphically and use the vertical line test to verify a function. So here's an example of a function. It's a polynomial function that passes the vertical line test. When we draw a vertical line, the curve only touches that vertical line once. And here's an example of a curve that's not a function. When we draw a vertical line, we could clearly see that that curve touches the vertical line in 3 locations. That means there are 3 y values that correspond to 1 x value. That is not functional. Intervals and interval notation are important to use and understand because they help us describe functions. Many times we'll describe the properties of a function on a specific interval, such as its domain or range, or whether it's increasing or decreasing. Here are some examples of intervals. Below each one, we'll write its corresponding inequality and what it looks like on a number line. Here are the inequalities. What I want you to notice is that a bracket means inclusive and a parenthesis means exclusive. For students who are familiar with open holes and closed holes, a bracket is equivalent to a closed hole and a parenthesis is equivalent to an open hole. Finally, here are the pictures of the number lines. When infinity is involved, that's called an unbounded interval. And when you don't see an infinity or a negative infinity, that's called bounded. Now it's time to talk about domain, which is probably the most important part of this lesson. It's a concept that will stick with you through your study of polynomial functions, rational functions, exponential functions, logarithmic functions, and trigonometric functions. Wow. When we talk about domain, there are 2 issues. Number 1, when we divide by 0. Number 2, the square or even root of a negative number. And I want to point out 2 things related to roots. We can take the cubed root or odd root of a negative number, and we could take the square root of 0. It's just 0. Now that we are reminded of or now know those 2 things, let's find the domain of 2 separate functions. A, f of x equals the square root of x plus 3, and b, g of x equals the square root of x divided by x minus 5. For the square root of x plus 3, in order to avoid the square root of a negative number, what we need is the expression x plus 3 to be greater than or equal to 0. By solving that inequality, we're finding the domain of that function. And the solution is x is greater than or equal to 0. Therefore, the domain in interval notation is bracket -3, comma, infinity, close parenthesis. In the second function, both issues show up, one in the numerator and one in the denominator. For the square root of x must be greater than or equal to 0. There's nothing else to solve. And for x minus 5, we can't let that be 0, otherwise we're dividing by 0. Therefore, we have x minus 5 cannot be equal to 0. We solve that, and we have x cannot be equal to 5. Since x must be greater than or equal to 0 and not equal to 5, that means x can be between 0 and 5 and greater than 5. So we have two intervals. The first interval is bracket 0, comma 5, close parenthesis. Then the union symbol, followed by open parenthesis 5, comma, infinity. We can visualize those intervals by creating a number line and plotting 0 and 5 on that number line. Then we put a bracket at 0 and two parentheses at 5, facing the opposite directions. And then we shade everything in between 0 and 5 and everything to the right of 5. There's the domain of the function. We can see it. Well, I hope that lesson was functional to you. You input some time and out comes knowledge. I appreciate you learning with me, and be sure to check out the description for more information and add a comment if you like. See you next time.